Okay, in this video, I'm going to demonstrate how to work out grad, divergence, and curl using some examples. So just for a recap, this is the formula for the gradient of a scalar phi. This is a formula for the divergence of a vector f, where f1, f2, and f3 are the x, y, and z component of the vector. And this is the formula for the curl. So here are our examples. This is our vector field f, and this is our vector field g. And then we've got two scalar fields, phi and psi. So these are the quantities we are going to work out. So the first one, we're going to work out the divergence of f. So divergence of f. Now f is 2xy squared. That's the x component, minus 4x e to the, it's actually minus 4z, e to the minus x, and the z component is 5. So the divergence is a scalar. It gives a scalar. So we differentiate the x component with respect to x. So that's going to give us 2y squared. We differentiate the y component with respect to y. You notice that the y component does not depend on y. We differentiate the z component with respect to z. Again, the z component is a scalar. So that means the divergence of the vector f is simply going to be 2y squared. And then next we need to work out the gradient of phi. Phi is 4xy squared. So it's just here. So we need the gradient of phi. So this is the grad of 4xy squared e to the minus 2z minus cosine 2x. So for the gradient, the x component, the gradient is going to be a vector. The x component of the vector is a derivative of phi with respect to x. So if we differentiate this term partially with respect to x, it's going to give us 4y squared e to the minus 2z. Differentiate this term with respect to x, it's going to give us plus 2 sine 2x. So that is the x component. Then the y component, we differentiate the function now with respect to y. Y only appears once here, so that is going to give us 8xye to the minus 2z. And then for the z component, z only appears once again in this term, so that is going to give us negative 8xy squared e to the minus 2z. So that is going to be grad phi. The next, in part C, we need to work out the curl of f. So we need to work out curl of f here. So we're going to have to work through this 3 by 3 determinant here. I, j, and k, partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. The x component of f is 2xy squared, so 2xy squared there. The y component is minus 4ze to the 4z e to the minus x. The z component is 5. So the x component of this, we're going to have to do the determinant of this. So it's going to be this operating on 5, which is 0, and then minus the z derivative of this. So z only appears there, so that's going to give us 4e to the minus x. And then for the y term, it's going to be the z derivative of this, which is 0. Take away the x derivative of 5, which is again 0. Then for the z component, it's going to be the x derivative of this, which is going to be 4ze to the minus x. And then take away the y derivative of this, which is going to be 4xy. So 4xy there. So that means our curl of f is going to be 4e to the minus x 0 and 4ze to the minus x minus 4xy. So it's going to be the curl of the vector f. Then next in our list of quantities to work out, we are going to work out the Laplacian of phi. So this is in part D, Laplacian of phi. There are two ways we can work out the Laplacian of phi. First, we can work out the grad of phi, which we've already done, and then take the divergence, or simply use the fact that the Laplace is simply the second order derivative with respect to x plus the second order derivative with respect to y plus the second order derivative with respect to z. So we can simply just take phi, differentiate it twice with respect to x, and then differentiate it twice with respect to y, then differentiate it twice with respect to z, and then add those three. Now we're going to recall that this is phi, so phi is for xy squared e to the minus z. So for xy squared e to the minus 2z minus cosine 2x. So if we take this thing differentiated once with respect to x, which we've already done actually when we did gradient. So it's just going to be this term here. So that is going to be 4y squared e to the minus 2z plus 2 sine 2x. Then if we differentiate this again with respect to x, there is no x dependence here now. So that term is going to be 0, and then derivative of this is going to be 4 times cosine 2x. So that's going to be this term here. Then now we differentiate phi with respect to y. So if we differentiate phi with respect to y, y only occurs there. That's going to give us 8xy e to the minus 2z. 8xy e to the minus 2z. So the second order derivative of phi with respect to y simply going to be 8x e to the minus 2z. Then lastly, we differentiate phi with respect to z. So z only appears in the first term. So when we do that, we're going to get minus 8xy squared minus 8xy squared e to the minus 2z. And then the second order derivative So we differentiate this thing again with respect to z. So that is now going to be 16xy squared e to the minus 2z. So that means the Laplacian of phi is going to be this term 4 cos 2x, 4 cosine 2x, plus the derivative, second order derivative with respect to y, which is 8x e to the minus 2z, and then plus this term here, 16xy squared e to the minus 2z. So that's going to be the Laplacian of phi. Then in part E, we want to work out the curl of f. So we've already worked out the curl of f up here. So that means we're going to take the curl of this function again. So curl of f is going to be given by, so the x component is 4e to the minus x, the y component is 0. So 4e to the minus x, the y component is 0. And the z component is 4ze to the minus x minus 4xy. So 4ze to the minus x minus 4xy. All right. So when we do the x component of this, so we're going to have to differentiate this term partially with respect to y. There's no y here, so the only y term is there. So it's going to give us minus 4x, and then take away z derivative of this, which is just 0. Then the y component is going to be the z derivative, this term which is 0. Take away the x derivative of this. So the negative of the x derivative of this, if we differentiate this with respect to x, it's going to be 4y. And if we differentiate this with respect to x, it's going to be just the negative of this, but then we already have a negative. So that's going to be 4ze to the minus x. And then the z component is going to be the x derivative of 0, which is 0, minus the y derivative of this, which is 0. So that is going to be the curl of f. Then the next example is the divergence of phi times g, psi actually. So psi is xy z squared, and g is there, so we just need to work out that product. So that's f. We need to work out psi times the vector g. Psi is xy z squared, and then multiply the vector g is x plus 2z, x squared y, 4y squared plus 3z. So if we multiply through by this scalar, then the x component is going to be x squared y z squared plus 2xy z cubed. The y component going to be x cubed yz squared. Just multiply this into that, and the z component is going to be 4xy cubed z squared plus 3xy z cubed. Okay, then we need to do the divergence of this. So divergence of psi g. So for the divergence, we just do the x derivative of the x component. So that's going to be 2xy z squared, derivative of this one. And then the next one is going to be 2y z cubed. And then derivative of this term with respect to y is x cubed z squared. Derivative of this term with respect to z is going to be 8x y cubed z, and derivative of this term with respect to z is 6xy z squared, and that's going to be that. So beyond that, we just look for like terms, and we notice that we've got xyz squared here, xyz squared there, so it's going to give us 8xyz squared. Otherwise it looks like those are the only like terms, so plus 2yz cubed plus x cubed z squared 8xy cubed z. So that's going to be the divergence of psi times g. All right, at this point we are going to give you a moment to work through the remaining examples. So if you would like to have a go at these ones, G all the way to J. So I think what you might want to do is just copy these onto a piece of paper, your F, G, phi, and psi, and then work through these. You might want to pause the video, and then when you continue the video, you can compare with our solutions. Right, we now scroll down to show you our working for these examples. So for the first one, G, the divergence of G just works out to 1 plus x squared plus 3, which is just going to be 4 plus x squared. And then the grad of psi, this is psi. I differentiate this with respect to x, we get the x component, differentiate this with respect to y, and then derivative of this with respect to z is 2xyz. And then the curl of g, these are the components of the vector g, so actually we can just refer here for the divergence. Derivative of this with respect to x is 1, which is where we got that. Derivative of this with respect to y is just going to be x squared, and derivative of this with respect to z is just going to be 3. So that's where these 3 terms came from. And then for this one, derivative of this with respect to y is 8y, derivative of this with respect to z is 0, and then derivative of this with respect to z is 2, derivative of this with respect to x is 0, derivative of this with respect to x to xy, derivative of this with respect to y is 0. So that's going to be the curl of g. And then lastly, we need to work out the curl of psi times f. So first of all, this is psi. This is f, so multiply through because this is a scalar. And then these are the components we get. And then we simply plug this into this 3 by 3 determinant. So derivative of this with respect to y is going to be 5xz squared. And then this with respect to z is going to give us this one. And then this with respect to z going to give us that. And then that with respect to x is going to give us 5. Just one moment here. So derivative of this with respect to z gives us 4x squared y cubed z. And then this with respect to x, it should just be 5yz squared. So here. And then lastly, so this with respect to x, we're going to have to use the product rule here. So we get two terms. Then take away derivative of this with respect to y is going to be 6x y x squared y squared z squared, and so that's going to be the curl of psi times f. All right, thank you.